May pinost ako na prob set, no? Yung prob set number 3. So, wala siyang deadline. Magpapasa lang kayo tuwing kung trip nyo na magpasa. Pasa nyo sa lab. Okay, so not necessary next meeting na lab yung siya ipapasa. So, wala siyang deadline. Gusto nyo, hindi kayo magpasa, okay lang. Then, hindi okay. Siyempre, walang grade pag walang hindi nagpasa. Ang point ay hindi ko siya nalagyan ng deadline para hindi kayo ma-pressure into doing it. So, try nyo lang on your own. No? Huwag na kayo magkopyahan dun. Try nyo lang siya para pagdating sa exam, hindi na kayo nakakonfuse sa mga bagay na katulad na ganun. Okay? Okay. Sige. Lesson tayo. Lesson tayo. Okay, game tayo dito sa next topic natin. So, ang next topic natin would be OpAmp na RC circuits. Okay, so maghahanap tayo ng ibang purpose ng OpAmp using RC circuits. Okay, so first things first, unang example natin would be yung integrator. So, tingnan natin to, solve natin to kung paano natin solve to. As usual, mag-KCL ka kung saan pwede. Mag-KCL ka kung saan pwede. Okay? So, VI minus V minus over R must be equal to the current across the capacitor. Okay, which is equal to C times yung voltage, derivative ng voltage, no? Kung naalala niyo pa. Derivative ng voltage across it. So yung voltage across it would be V minus VO. Okay? So IC is equal to dVC over dt times C. Di ba? So recall lang yan. Okay, so ayan na, meron na tayong equations. Hiwalay na lang natin. Equal to C times dV minus over dt minus C dVO. Okay, so in-apply ko lang yung derivative across dito sa dalawang terms dito. Dinistribute ko lang bale. Now, magandang gawin ay negative feedback, and then I could adjust VI such that active region or hindi tayo nasa saturation region ng OpAmp. So I can do the simplification that V minus approximately equal to V plus. And V plus, we know that it's the ground. So we have mawawala lang yung mga may V minus terms. And then simplifying this further, isolate ko si VO sa isang side. Tapos divide ko by C. Then I have VI negative RC. Tama. Okay, and then gusto ko ng output. Bakit po ulit sir naging V plus equal to V minus? Ito yung natin last lesson natin. Na kapag Kapag ito, hindi saturated yung OpAmp tapos feedback is negative, we can do this. Okay? Okay, going back. Sulat natin to, so integrate natin to both sides. Then we will actually obtain the formula for the integrator. Okay? So indefinite integral to. So variable, kunyari variable yung input mo. So integrate nyo yun. Nakadepend yung ano, wala tong bounds kasi 'di ba continuous input mo. So in-integrate niya agad yung form ng input. Okay, you might wonder, no? You might wonder. Paano ba ginawa natin yung usual way of doing the op-amp circuit? Yung merong VO is equal to A, B plus minus, B minus. So sige, try natin to ang ganito. You'll actually obtain a more accurate form of the equation. Okay, saan tayo sige. From here, I could plug in ko na agad si V plus kasi alam natin si V plus ay 0. So VO is just the gain times yung V minus. Tama ba? Kasi 0 out ito. 0 out to. Kasi nakakonect siya sa ground. Okay. Ayan. Now, things are easier na. Oh. Let me do this. So, palitan ko lang si V minus ng VO like this. And then, plug in ko siya dito. Plug in natin siya dito. So, we have VI over R. Tama ba? VI over R minus VO. Tapos may minus pa siyang isa. So, pinlagin ko lang dito, no? Pinlagin ko lang dito yung V minus. So, yung V minus natin, negative VO over A siya. So, ayusin lang natin. Gawin natin plus. And this is equal to yung mga derivative na. C over A, tapos may minus sign, D, VO over DT. Nice. Tapos C over A, DVO. Tama ba? Walang A. Yan siya. Tapos, ayusin na lang natin. Ayusin na lang natin yung form niya. So, factoring things out, we have this. And then, The other side, have those. Ito ay okay. Simplify lang natin, ayusin lang natin pa ng onti para mukha siya familiar. Lipat ko lahat sa left side para walang negative signs. Tapos factor out ko yung C. Ito ay 1 over A plus 1. Multiply ko na both sides. Pagsamahin ko yung dalawang 1 over A plus 1. So magiging all over A, tapos 1 plus A. And then plus VO over AR. And then plus VI over R. All equal to 0. So far, so good naman. No? So far, so good ba? Tapos, multiply ako ng A over 1 plus A on all sides. Tsaka, divide ko by C para walang factor tong first derivative ko. And I will obtain something like this. Plus, so multiply ako ng A, di ba? Both sides. So magka-cancel na yung A dito. Tapos i-divide ako ng 1 plus A. So magkakaroon ng 1 plus A factor dito. Tapos, di-divide din ako C. So may C factor din dito. So I have 1 plus A. Tapos RC plus VI. Merong A dito. Kasi walang ika-cancel out. Tapos RC 1 plus A equals sa 0. Okay, check ko lang notes ko. Tama naman. Okay, so ito yung itsura nung equations natin. Okay. Now, familiar na kayo sa itsura niya. So ito ay derivative ng x plus some constant letter a prime x plus another constant b prime equals to 0. So ito yung form niya. Naalala niyo yung solution dito from last sem. Ito ay exponential, di ba? Okay, exponential yung sagot dito. Tapos, pag 0 si b prime, yung solution nito, yung non-homogeneous, ay yung homogeneous solution. Something ganito yung ganyan yung form niya. Pag something ganito. Ay, mali. Something na ganyan, itsura niya. Okay? Yung charging tsaka discharging natin, naalala niyo sa RC, sorry. Sa RC circuits natin, may charging tsaka discharging yan tayo. Plots tayo kung naalala niyo. So basically, pag sinolve mo to, pupunta ka sa ganitong form. Okay? Mapupunta ka sa ganitong form. Now, hindi siya masyadong informative sa atin now kasi mapansin natin na ang sagot dito ay exponential. Pero sabi mo kanina, integrator circuit to. So dapat nag-integrate siya. Bakit exponential nun lumalabas? Okay, tingnan natin ngayon yung time constant nung circuit natin. So yung circuit natin, time constant niya lagi nandito, di ba? Nasa X term yung ano. So yung time constant natin would be 1 plus A. Tau natin would be 1 plus A plus R times RC. Okay? And then kunyari, yung time constant natin usually maliit to, di ba? Yung RC, at least yung RC. Maliit na bagay ito. So para ma-charge mo agad yung capacitor or para mag-respond agad yung capacitor. Mababa yung RC natin. However, yung 1 plus A natin is a very large number. So yung time constant natin would actually be very, very large. Okay, so anong point nun? Try natin yung equation natin na to. Ito yun na. Yung equation natin na to by putting a constant input. So mag-step input tayo na constant. That's VI equal to V. So ganito yung tsura. Try natin. So ano dapat yung lalabas kung integrator siya? Constant, ano yung pag in-integrate mo yung constant? Di ba linear? Linear dapat lalabas pag in-integrate mo yung constant. So line dapat lalabas dito. And then looking back at the integrator formula, negative yung slope. So kung constant yung input mo, integrate mo siya, magiging linear, tapos pababa. Okay. Now we just have to plug things in. So hindi natin solve actually. Plus VO. RC. And then plus VI. Yung VI natin would be V. Alright. Okay. So equal to 0. Okay, and then pag nilipat natin sa kabila ito, this is lagyan natin ng ganito. Para kita natin yung variable. Okay, so nilipat ko lang sa kabila. Gusto ko lang ma-point out na ito yung time constants. Tapos yung general solution for yung solution dito general. No? Solution for this would be yung charging ito. So charging plot dapat to. AV times 1 minus E raised to negative T. Teka. negative t over yung time constant, which is 1 plus a RC. Okay? So, ito yung itsura niya. Ano. Pag pinlot natin yan, ayan siya. Pag pinlat natin to, exponential naman siya, pero sobrang laki ng time constant, kaya sobrang tagal niya din magiging exponential. Okay, so mukha siyang linear. Mukha siyang linear. Okay, mukha siyang linear. So yung time constant mo sa scale ng days. So days pa siya bago umabot sa point na kukurba na siya. Kaya siya mukhang integrator. And by that time, saturated na yung saturated na yung dito. Yung OpAmp kasi AV yung pupuntahan niya, 'di ba? Yung output ng OpAmp can go as far as your supply lang. So it won't reach that amount of voltage, a very large voltage. Okay, so nakuha natin yung goal natin. Naglagay ka ng constant input, in-integrate mo siya linear, tapos negative yung slope. Ito yung lumabas. Linear, negative yung slope. Nice, nice, nice. So ayan, nag-integrate tong circuit na to. Okay, so itong circuit na to nag-integrate. And then, syempre, yung counterpart nito would be the differentiator. So, nangyari lang ay binaliktad mo lang sila actually. So, doing KCL, as usual, KCL ka dito, IC, yung current across, going through the capacitor, must be equal to the current along the resistor. So, that is V minus VO all over R. And writing down IC explicitly. So that is C times derivative ng VI minus V minus. Okay, and then negative feedback ba? Okay, I can just do the approximation that V minus is just equal to V plus. And then V plus is connected to the ground. We therefore have V negative VO all over R. So nawala lang yung mga V minus. This is just C D VI over dt. And this is it. Ayusin na lang natin. VO negative RC dVI dt. Okay? So output ay derivative lang ng input. Kanina, output ay derivative na, ay integral ng input. Ngayon, ano na siya, differential na. Okay, nice. So kapag naglagay ka ng step input, ano itsura nung differentiator graph? Dirac delta. Okay, kasi walang slope dito. So, pag dinifferentiate mo, 0. Wala ring slope dito. So, pag dinifferentiate mo, 0 din. Tapos dito may infinite slope ka. Magiging Dirac delta yung lalabas. Okay, pero hindi natin try. Okay na yan. Alright. Ang next na gagawin natin ay a more complex one. So, active filters ang pangalan nito. Itong circuit na to. So, meron siyang dalawang resistor, meron siyang dalawang capacitor. So, let's try this. Let's try doing this. Okay. So, wag mag-panic. As usual, mag-KCL ka lang. Anong practical use ng differentiator tsaka integrator? Kapag meron kang waves, tapos gusto mong baguhin yung form niya. So, para makagawa ka ng square wave, actually, kailangan mo ng mga ganito. Kailangan mo ng triangle wave, kailangan mo nito. Differentiator tsaka integrator. Okay. Sige, bigay tayo ng next meeting ng practical uses. Okay, but first, gawin muna natin to active filters na circuit natin. So, magde-designate muna ako ng currents para hindi tayo mahirapan tumingin. So, going out of the supply, punta siya sa node V1. And then sa node V1, split into 2. Going there. Going here. So, syempre wala dito. Wala rin dito. Going here. Going there. Okay. And then, KCL ako at these points. Dito. So, I have two equations. Then, I will just combine them later. Sa V1 muna. VI minus V1 or 1 must be equal to two terms tayo. Yung isa, current sa capacitor number 2. So that's C2. Derivative ng V1 minus VO. V1 minus VO. And then for the next one, V1 minus V minus. Okay. V1 minus V minus. And then the other one is yung current dito must be equal to sa current to sa R2. So we have C1 V1 minus V minus. Let's double check that. V1 minus V minus. Okay. And then that must be equal to V minus minus VO all over R2. Okay. Okay. Let's do this. Gusto natin ma-eliminate si V1. Di ba? Kasi gusto lang natin malagay in terms of VO and VI. Okay. So how do we do this? Okay, first things first, mag-apply ako ng approximation ko. So negative feedback. Okay. And I could just go away from the saturation region. So VI must V minus would be approximately equal to V plus. V minus approximately equal to V plus. And then since V plus is equal to 0, then I could just eliminate those terms. Let me just mark them out. So ito wala. Ay, hindi, ayusin natin. Formally. Okay? Okay? Okay. No. Wala na. Okay. Now, mas malinaw na siya kahit pa paano. So, let's write them down again para hindi tayo mahirapan. Vi minus V1 over. Isa-isayin na natin yung denominator. R1. R1 must be equal to C2 dV1 over dt minus C2. Iniwahiwalay ko lang yung terms, guys. dVO plus C1 dV something which I forgot. V1. Okay? So, ito na yung unang equation natin. Yung pangalawang equation. So, hindi ko siya pina-plug in. No? Pwede mo nang plug in dun, pero that wouldn't make sense kasi hindi mo naman matatanggal yung yung mga bagay-bagay. So, ang goal natin is VO must be in terms of VI. So, V1 yung eliminate natin. C1, second equation na tayo. V1 over dt. And then, this is equal to negative VO over R2. Okay. Now, let me just divide this second equation by C1. Nakikita nyo na ba yung form? Divide ko to by C1. Okay. So, si dV1 dV1 over dt, pwede ko i-plug in dito sa mga to. Kasi may mga V1 sila. Now, I just have to take the derivative of this whole thing. No? Kasi ito kasi walang derivative eh. Wala siyang derivative. So, di-derivative ko lahat sila. Okay. So, kunin ko na rin derivative nito para meron akong second derivative. So, let's do that. Let's write them down in green para alam natin yung mga naka-derivative na equation. Okay. So, dVi over R1 minus dV1 over dt. Nawala yung dt dito sa kabila. Okay. And then C2 equal to sa C2. Second derivative V1 pala. dt squared. Tapos minus. Pwede nyo gawin sa exam to, yung nagko-color code ng ng equation. Okay lang maging colorful yung paper nyo. No problem. C1. Ay, hindi ko na derivative itong pangalawa. Ito ay, kalimutan ko agad. C1, then second derivative ng V1. Okay, so naka-second derivative na sila lahat dito sa right-hand side. Tapos, derivative yung kaliwa. And then we're almost done. Second derivative ko lang din to. dv d squared v1 dt squared. And then negative d over dt ng VO. Tapos ito ay R2C1. Okay? Now, what's next? Ito, ipa-plug in ko dito. Kasi may dv1 over dt. Ito, plug in ko dito. Ito, plug in ko dito. Okay, so may eliminate natin lahat ng V1. So let's do that. So sabay nyo lang ako, no? dv1, dvi, tama. R1 dt minus VO over R2 C1. Okay, so pinlog in lang natin dito. Tapos equal to sa C2. So bababa siya. Magiging negative dVO over dt. Tapos magiging C1 R2 sa denominator. Nice. And then yung second term would be unbothered. Kasi wala namang gagawin sa kanya. Then the last term would be plugging in this guy to this one. So C1, magiging negative. Magiging negative C1 over C1 over R2. Mamaya ako na sila ka-cancel. Baka mamaya helpful pala yung ganyang relation. Okay. Now we have plugged in everything. So kung ang ano na lang ay ayusin to, no? Ayusin natin so that tayo naguguluhan in life. Okay. So lipat natin tong lahat ng nasa right hand side into the left hand side para mag-flip lang yung mag-flip yung signs. Teka, may comment daw. May comment na missing. Ito, yung second term, no, may R1 dapat siya. Tama ba? Ayun ba yung ano? Di po. Tama. R1, R2. Tama. Okay. Sorry. Na-miss out siya. Okay, anyway, naayos na natin. Lilipat lang natin to the left-hand side para mag-flip yung signs. And ayusin natin so that yung orders nila descending. So I have C2 D squared VO all over dt squared plus C2 C1 R2. Tapos pansinin nyo, ito ay dVO over dt rin. So combine ko na silang dalawa. This is C1 over C1 R2. Buti na lang, di natin yan kinancel agad. And then, what's next? VO. So this one, yung VO. VO, R1, R2, C2. And then lastly, yung input term plus dVi over dt times yung R1. Okay, all equal to 0. Okay, double check lang natin. Looks good, looks good. Okay. Then I could just divide everything by C2. Oops, may mali ako. May mali ako. Ito ay C1 dapat to. Ito. C1 siya. Ayan na. Ito, going here. Nagawa ko siyang C2. So C1 dapat siya. Okay, very good, very good. May nakapansin. Thank you, thank you. Okay, now let me just do this. Divide ko lang everything by C2. So R2, C2, C1, plus C2, C1, dVO, dt, and then plus 1 over C1, C2, R1, R2, VO. Tama, di ba? Nag-divide kasi ako by C2 everywhere. So, extra factor na C2 dito. Tapos, lastly, plus 1 over R1, C2, dVi over dt equal to 0. Okay, anong point? Anong point natin? Na-solve ba natin yung problem? Well, na-solve na natin yung input-output relationship. However, hindi siya masyadong familiar sa inyo. Perhaps, bigyan natin siya ng a more meaningful outlook to it. Naalala niyo yung Naalala niyo yung RLC circuit? So, baka hindi na. So, RLC circuit plus minus R L, kaya ko to, yan, C. And usually, kinukuha natin yung output dito sa capacitor. And yung equation yan would be DC dt squared plus R over L dVc dt plus 1 over LC VC must be equal to 1 over LC V in. So yung V in mo itong okay? And if you look at these two equations, parehas sila ng differential equation. Ito, second derivative, constant times yung first derivative, constant times yung first derivative, yung constant term naman ay yung walang derivative na term. So constant times yung variable mo, constant times yung variable mo. Then at the other side is that yung input mo. Yung last term would be the input. Okay? Ito naman ay independent dito sa transformation ng V output mo. No? So this whole thing can be reduced into some input V in. Okay? The point is, nakagawa tayo ng RLC circuit by just using capacitors and resistors. So very important to kasi sa manufacturing ng integrated circuits ng mga devices natin. Mahirap mimic ng inductors kapag inductors talaga. So we have to make do na capacitors gagamitin mo instead of inductors to produce the same effect. Okay? So mahirap gumawa ng maliit na inductors, in short. So yan, nakagawa tayo ng our resonator circuit, RLC circuit natin by just using 2 capacitors and 2 resistors. So ito, pwede mong baguhin. Constant lang naman to, di ba? Constants lang naman to. Yung R over L, kaya mong i-replicate yan through this. Okay? So constants lang sila. Tapos itong same dito, ganun lang din naman. Constant lang din naman yan. Can actually modify this to accommodate it to look like this. Okay? Okay. So, teka, tignan pa natin yung more important. So, dun sa RLC circuit natin or sa mga energy storage element na circuit natin, meron tayong alpha at omega naught. So, yung alpha yung bandwidth natin. Bandwidth pa yun. Hindi pala. Teka. Bandwidth nga. Tsaka yung omega naught yung resonant frequency. Okay? Anyway, yung alpha would be, kung titingnan natin sa equation na to, this is actually R over 2L. So kalahati nung constant na nakamultiply doon sa first derivative term. Okay? And then omega naught would be yung factor na kasama, square root ng factor nung kasama nung constant na to, yung walang derivative. So omega naught squared is just 1 over LC. Okay? Ito yung resonant frequency kung naaalala nyo. Or kung omega naught yung gusto nyo, syempre square root yun na lang. But anyway, kung ipapattern natin to, si alpha in this particular equation would become yung kalahati ng constant na nakamultiply. So C1 plus C2. C1 plus C2. Then R, nakalimutan ko. R2. Okay. Yan. And then yung resonant frequency natin on omega naught would be yung constant na to. Okay? Katabi nung V naught. Ay, VO. 1 over R1, R2, C1, C2. Okay? Okay. Now, parang hirap naman. Naka-time variables pa tayo. Pwede ba natin gawin to sa ano mangyari pag ginawa natin siya sa impedance model? So let's do that. I think this is a lot easier. Okay, so try natin no, na impedance model. So unahan nyo na ako para tapos na yung notes nyo. As usual, ganun lang din gagawin ko. KCL ako dito tsaka dito. Same flow nung currents. Okay, so let's do that. VI minus V1 all over impedance nung resistor, which is just same R1. And then plus joke equals okay. Pag naka-impedance model, mas madali, no? Mas madali na yung isang equation na lang tayo. Itong pathway dito, mapapagsama ko yung ano nila, di ba? Mapapagsama ko yung impedance nila. So, naka-series yung impedances nila. So, with that, V1 minus VO all over yung sum ng impedance, which is R2 plus 1 over SC1. Okay, 1 over J omega C. And then the other path would be here sa taas. And simply, this is just V1 minus VO all over 1 over SC2. Okay. Now what's next? Simplify natin. Okay, pangit pala. Kailangan pa rin pala natin yung yung voltage dito sa V minus. So, I would have to evict this guy. Ay, yung R2 pala dapat. So, V1 minus V minus. Okay. Ito. So, magdadalawang equation ako. Okay. Same pa rin naman yung mangyayari. Ito ay 1 over SC1. Okay. And then the other equation would be V minus VO all over R2 must then be equal to yung current dito, which is V1 minus V minus all over 1 over SC1. Okay, pangit. Okay, so let's do this. First things first, ayusin natin yung mga fractions. Ang gugulo ng fractions. So, let's try to make things neat. Okay, so first thing, niwalay ko na yung yung fraction nito. R1 minus V1 over R1. Mag-flip lang to. So, mag-multiply lang yung SC1 to these terms. C1, V1, minus SC. Oh no. Tabi na natin yung equations. Sige, baba na lang pala ako. Okay, so baba tayo. Ito na lang. Ulitin natin. VI over R1 minus V1 over R1 must be equal to SC1 V1 minus SC1 V minus plus SC2 V1 minus SC2 VO. Okay. Ayan. Tapos, ano next natin? Yung other equation naman. Yung other equation naman would be V minus VO over R2 over R2. And then SC1 V1 minus SC1 V minus. And then let's invoke the yung assumption natin na naka-negative feedback naman and so on and so forth. Magzi-zero lang naman yung V minus. So let's do that. This one. And then same thinking process. VI over R1 minus V1 over R1 plus SC1 V1 ay V1 dapat yan plus SC2 V1. So be careful sa ganun, no? Be careful sa what if V1 tas malalagay nyo siya as VI. So minsan nagiging habit natin. Nung pagka-graduate ko ng masters, puro H-bar yung ginagamit ko. So lahat ng mga sinusulat ko in life nag-automatic naggaganyan. Nasanay na ako. So be careful sa muscle memory. Sulat natin tong second equation but isolate na natin si V1. So I have V1 to be negative VO over S R2 C1. Then I would just have to plug things in. VI over R1 minus SR1 R2 C1 equal to sa SC1 tapos negative VO over SC1 R2 and then plus SC2 V1 din pala siya so magma-minus yung sign. And then denominator SR2 C1. Lastly, SC2 VO. Okay. S terms cancels here. X factors, C1 factors. Okay, anyway. Ay, dapat pala hindi ko na kinancel. Huwag natin cancel. 14. Bakit hindi ko kinancel? Same kasi ng denominator na itong dalawa. C1R2. C1R2. So ngayong task na lang natin ngayon is i-isolate si VO. Tapos ilipat si VI. Okay, so lipat natin lahat. I-flip natin yung sign ng lahat. No? Lipat natin tong right-hand side to the left-hand side. Tapos itong isang term dito to the right-hand side. So, VO. Tapos, SR1, R2, C1. Tapos, ito ay equal sa C1. No, lipat nga pala natin. C1 plus C2 all over C1 R2 VO. So nakuha niyo yun dito sa part na to. Pinagsama ko sila kasi same denominator. Tapos pinactor out yung negative sign. So magiging C1 plus C2. Tapos since ililipat ko sila lahat pakaliwa, yung negative sign would be obliterated. I'm left with this. Tapos minus SC2 plus dapat siya. Kasi nilipat natin. Okay, and then lastly, yung negative VI over R1. So gusto natin malinis natin lahat para ano na lang siya. Pangit naman ito. So, factor out ko lang yung VO. Ayun na yun. Ito ay VO. I think may mali ako somewhere. May mali ako somewhere. Okay, let's go back. Let's backtrack a bit. May na-miss ano ako. May na mali ako ng sulat. Teka, double check ko lang notes ko. Hindi. Tama lang pala. Tama lang. Okay, factor out ko yung VO. Sige, let's do this. This is 1 over S R1, R2, C1 plus this whole thing, C1 plus C2 over C1, R2, and then plus SC2. Okay, and then this is equal to negative VI over R1. Then divide ko tong whole thing na to dito para mapunta dito sa kabila. So, yung numerator ko, medyo mahaba to. Ito ay okay, so kinokopya ko lang, no? And then numerator ko would be negative VI, negative 1 over R1 times VI. Okay, and now let's make this more familiar. So, di ba ito ay transfer function? Transfer function to, di ba? Then usually, you want your denominator to be in the quadratic form or S plus A terms. Okay, pero I think this is quadratic. Okay, kasi hindi mo magiging S plus A ito kasi may 1 over S dito. Sige, factor out ko yung 1 over S. 1 over S. So, I'm left with 1 over R1, R2, C1 plus S times C1 plus C2 over C1 R2 and then plus S squared C2. Now, gusto natin walang factor na katabi si S squared para mabalik siya doon sa usual form natin na alam natin from 180. Sana naalala nyo pa. But it's okay if not. Factor out ko rin yung C2. C2. So I have here negative 1 R1 VI. And then factor out ako ng C2. So C2 over S. And this is just 1 R1 R2 C1 C2. Tapos plus C1 C2 R2 C1 plus C2 plus S squared. Ay, yung S natin, nakalimutan. Okay? Now, ito lipat ko na lang ito dito sa taas. You can actually do that. So magiging factor siya na mag-flip to dito sa taas. Oops. Ito ay magiging S C2 R1. Okay, so nilipat lang natin yung extra factors dito. Okay, so ito na yung final form. And then since nakita natin yung denominator na ganito siya, this is actually, di ba, yung usual form natin ay S squared plus 2 alpha S plus omega naught squared. Okay. So as usual, nakuha natin to. Nakuha rin natin to. Same as before. Isa yung kanina. Kung mahanap yung kanina. Ayan, nakuha natin siya. Same naman. Okay, so ayan ang active filters natin. Tinawag siya na active filter kasi gumagamit siya ng active component which is yung OpAmp. Yung dati natin mga filters passive sila kasi passive components yung ginagamit. Parang circular definition. Anyway, makakagawa ka ng RLC circuit using just resistors and capacitors. Then syempre pwede mo ring ma-reduce to into yung low pass and the usual low pass and the high pass filters, which we will cover next meeting. Okay? Okay. So ito ay in general muna, RLC, resonator circuit. Okay. So ayan, any questions? Any questions? May meeting tayo this Wednesday. Tapos wala tayong meeting sa 26, sa November 2. And then may meeting tayo ng November 9. Tapos DE nyo would be November 16. Then after that, you'll start building your final project. Okay, any questions? Any questions? Okay, sige. Kung wala, Mag-check muna ako attendance. Sa final project po ba parang yung group po ba mag-iisip nung i-build? Hindi. May ipapagawa ako sa inyo. Tapos pagandahan ng magagawa. Ayun yung yung mangyayari. Okay, so attendance tayo. Sige, yung mga gusto magbukas ng camera. Okay, sige. 1, 2, 3, smile. Okay. Sige. Kung may further questions kayo, sendan nyo lang ako ng email or message sa Canvas. And good luck sa exam nyo bukas sa 151. Bukas exam nyo, di ba?